Standing in a gale puts you at the center of a massive transfer of kinetic energy. Here on Earth, we spend our lives completely submerged in a relentlessly dense ocean of gas. Our atmosphere is packed tightly. At sea level, the average distance an air molecule travels before slamming into another is roughly 68 nanometers. This crowding guarantees any localized movement triggers an immediate chain reaction of collisions. This domino effect is what we call sound. It is a mechanical wave, a series of high-pressure compressions pushing through an elastic medium, leaving low-pressure wakes behind them. Human biology evolved to capture these rapid atmospheric collisions and translate them into a stream of sensory information. We take this auditory feedback for granted, but the experience is highly conditional. It relies on a dense structural foundation that disappears the moment we leave our atmosphere. Move past the planetary orbits and out into the deep intergalactic void, and the physical rules of sound propagation dissolve. Out here, the emptiness is nearly absolute. In the massive gaps between galaxies, matter density collapses to less than one single atom per cubic meter. Suppose a cataclysmic event occurs in this environment, like a dying star detonating into a supernova, releasing a massive surge of kinetic energy. The explosion displaces the atoms in its immediate vicinity, but because the distance between each atom is so vast compared to the atoms themselves, these particles almost never hit another object. Without a continuous medium of particles, the mechanical energy cannot cascade. The wave instantly dissipates, trapped within solitary atoms coasting through the dark. The universe is an arena of constant titanic collisions. Yet, because matter is so sparse, the vacuum is structurally incapable of producing an echo. Occasionally, gravity traps enormous pools of superheated plasma between colliding galaxies. This is the intracluster medium. Here, the density rises just enough above the surrounding void to allow for the propagation of genuine acoustic phenomena. In 2003, researchers analyzing X-ray data from the Chandra Observatory found immense concentric ripples pushing through the plasma of the Perseus cluster. These were acoustic pressure waves generated by cyclical outbursts from a supermassive black hole. The scale of this sound is alien to our perception. The fundamental acoustic frequency produced by the supermassive black hole is a B-flat note sitting 57 octaves below middle C. A single acoustic wave cycle takes 10 million years to complete. As these waves push through the plasma, they transform their mechanical energy back into heat. This thermal injection prevents the surrounding medium from cooling and collapsing, regulating the birth of new stars. No biological organism can hear this tone, but it acts as a mechanical engine that shapes the largest structures in the universe. Contrast the cosmic scale with an astronaut inside an EVA suit. Pressurized oxygen isolates them from the silent universe, creating a loud internal acoustic chamber. Because the suit is lined with soft thermal layers, it acts as an anechoic chamber. Without echoes, the human brain loses the spatial clues it desperately needs to interpret distance and direction, leading to acute disorientation. Starved of external input, the auditory system begins to amplify internal noise. The click of ventilation fans is conducted directly into the skull. The friction of a breathing regulator and the thud of a heartbeat become the only sounds heard. This creates a unique psychological strain, watching massive mechanical events unfold in a silent void, while being deafened by the sounds of your own biology. To understand a universe operating outside our sensory threshold, scientists must gather non-acoustic data, like light wavelengths and magnetic field strengths, using instruments like the James Webb Space Telescope. This data is processed through sonification, a methodology that translates numerical values into audible frequencies. As shown here, techniques like spatial scanning or wavelength conversion allow us to assign pitch and volume to invisible light. The human auditory system is highly evolved to detect subtle patterns and temporal variations that might be overlooked in a purely visual analysis. For example, pulsars emit precise intervals of electromagnetic radiation. By mapping those intervals to audio, scientists create a rhythmic cadence, allowing them to audit the star's rotational stability by ear. By artificially giving the void a voice, We bypass the physical limits of the vacuum. We transform a silent universe into an educational symphony.